I've been trying to understand quantum mechanics for most of my adult life and can happily confirm to you that I still don't understand it, as indeed very few physicists really understand it if you ask them difficult questions about what it all means. And the quantum story really is literally the story of this rather perplexing and yet beautiful structure. Beginning in 1900 with the original discovery by Max Planck, German physicist, that fundamentally light is composed of discrete bundles of energy that later became called photons. Following through with Einstein, his wonderful genius and his ability to take that idea of Planck's and actually manifest it to accept what was regarded as unacceptable in the early part of the 20th century, and in effect to run with it and to produce ideas that were even more bizarre in their implications. And we trace the theory in the book through its formative years. In the 1920s and 1930s, the great debate between Albert Einstein and Niels Bohr, Danish physicist, about what quantum mechanics implied for the nature of physical reality itself. This was a famous debate characterized by some famous quotations. Einstein said that God does not play dice, pointing to the fact that quantum physics seemed to tell of a vagueness, a lack of cause and effect, an uncertainty right at the heart of the atom, if you like. Niels Bohr, more philosophically minded, argued that, well, there's a simple fact that we have perhaps reached a level where we can no longer expect to understand what it is that's going on, even though these things make up atoms and atoms make up everything that we see and everything that we are in the physical world. But the story continues. Often histories of quantum physics talk about this wonderful debate between these two great Nobel Prize-winning physicists. But there's a lot more. And in fact, if you want to understand what's going on in contemporary physics with CERN, the Large Hadron Collider, the hunt for the Higgs boson, you are better off doing that, I think, with an understanding of the history of the physics that's preceded it. So the book traces the development of quantum electrodynamics, a formal structure using quantum theory to understand how electrons interact with light. And then in the 1950s, 1960s, various theories that allowed us to get inside the nucleus of the atom, to understand the fact that protons and neutrons are made of quarks. Theories of the strong force that holds these particles together inside the nucleus, leading to what physicists know today as the standard model of particle physics. And if you want to know what's going on at CERN, then in effect this is really the basis of the quantum theory that is being tested. Aspects of the structure of the standard model are still a little bit uncertain, a little bit in doubt, and CERN is looking to hold all of this together. The book closes with a reflection on the nature of quantum reality, a section looking at very contemporary experiments designed to test the nature of the debate, if you like, that took place in the 1920s and 1930s between Einstein and Bohr. And without going into any details, I can tell you these experiments really come down very firmly on the side of a really rather bizarre world out there that we can barely pretend to understand.